spending your Saturday, at 4 p.m. My father went to the football game today, and he couldn't be bothered to come to this talk. But all of you did, so that means a lot to me. We get along just fine. I'm just kidding around. All right, hold on. How do I... It's pretty bad, isn't it? Do you know? Yeah. It's probably downstream of the mic, I imagine, right? Well, if I turn it off. Yeah, that's probably doing it, isn't it? This isn't plugged into audio, but do you have another? I guess I can just send the deck over. Okay. Okay. Yeah, thanks for spotting that, actually. It was pretty bad. This is on Google Drive, so I can probably move it over. I mean, is this just always going to happen? Okay. Sounds like it's gone. Awesome. Okay, this is back on. Great. Okay. Hi, how you guys doing? Ladies, gentlemen, etc. You can hear me fine? Everything's good? All right. Again, thank you for taking your Saturday afternoon to spend some time with me here. My name's DavidAlbrechtr. I have a couple goals for this talk I'm going to go through. So it's kind of a boring intro, but basically I want to talk about 4 things, I think kind of 4 motivating influences behind this talk. So first one is that I work at a company in San Francisco that's responsible for operating a very substantial collection infrastructure for a bunch of data on how mobile apps are performing on phones. So I think it's kind of interesting to sort of step out of the Silicon Valley, mold, bubble, whatever, comment a little bit on that. That's something. I'm hoping to give you some perspective so that if you want to go out there and work, you'll kind of know what you're getting yourself into, for better and for worse. Second thing is that I want to talk a lot about what operations engineers at companies today do all day, because it's not something that you talk about very much here in school, and unless you have direct knowledge of it, it can actually be pretty hard to learn about. And the problem is exacerbated by the fact that a lot of what goes on in this industry is fairly secretive for a lot of reasons. Part of that is because companies don't always want to know or want other people to know where their stuff's located for confidentiality concerns, other issues like that. And also that it tends to be a bit more of a craft profession. Like people do it kind of they learn about it by doing it, not so much by reading about it in a book. Third thing is that I want to get you thinking about this problem space, because I believe, and I think as does Alex, that there's going to be a lot of innovation here in the next 10 or 15 years because of some economic factors that I'm going to cover in this talk. So I think that if you're looking at working somewhere, or if you want to start a company, or in general just interested in what's going on in the world, I think there's going to be a lot of innovation here. So pay attention to that, obviously. And the fourth thing is I want to tell you guys some stories, because I've been through a very stressful and kind of terrible last year. And I just want to share some of the things I've learned during that time. So anyway, let's get started with this. So to reiterate, my name is DavidAlbrechtr. I graduated from this fine university in 2007 with a bachelor's degree. I went on to complete a master's degree under supervision of Nikita Borisov in 2009. Don't tell him I'm here. I didn't tell him I was coming, and I feel a little bad about that. When I graduated with a computer engineering degree, so I was actually quite interested in hardware. And to this day, out in San Francisco, a lot of my friends that are out there are more on the hardware side. They work at places like Apple, Intel, AMD, places like that. But it turns out that knowing a lot about hardware is actually makes you a pretty good operations person, because a lot of what I had to do during the first year of this company where I worked at Criticism, which was design the hardware infrastructure and platform, which is like picking which instance sizes we wanted to use, how much memory they should have, how to scale all the processes, how to set up the network, do all this kind of stuff. So having a little bit of a hardware grounding made that a bit easier. Also, I think I was mentioning to somebody before the talk that having some statistics background really helps as well. So in terms of like the kind of 15-second overview of my own career, I worked at Microsoft for a little while, decided I didn't like the particular job role I was in, not the company, but just the job role I was in. So I started a consulting company, which I ran for a year and a half, kind of put that on the back burner, did a startup, sold the startup to a company called Zenbox. Now I was the 4th engineering employee at a company called Criticism. So this is our logo, Criticism. This is meant to connote strength. I think it's kind of cool. I think our graphic designer did a pretty good job. It's kind of supposed to look like the side of an I-beam here. You can kind of see that. But it's shaped like a C. And what the company does is that if any of you have written normal like desktop software, like old school style, there's a lot of stuff that you can drop into this software to tell how it's doing, like when it's released out to production. And it turns out that when you send software out into the world, as opposed to running it on a web server or in some sort of a controlled infrastructure, it's pretty hard to monitor. And it's funny that we've kind of gone like full circle on this, because we went from like mainframes 20 or 30 years ago out to PCs, where everything kind of went distributed, and then everything went to web apps, so it all came back in, and now we're moving to this world where everything is going to mobile apps, so it's all back to distributed execution now, okay? When you ship a mobile app out to the world, you want to know, the most basic operational metric is my app crashing? Like, what is my crash percentage? At Criticism, we monitor approximately 200 million phones, like every single day. So we track like when apps are being used, when they're not being used. So we know things like what the aggregate crash rate is. I think it's something like 0.6 or 0.7% of iOS sessions actually end in an unhandled exception of some form or another. We do a lot of analysis to group all of that together. We also track the amount of data that goes in and out of the network and what services people are talking to. We sometimes joke internally that we want to make the status page of the internet, because we have a very complete and accurate data set for what internet services people are using, like Pinterest and Facebook and LinkedIn and all these other sorts of services, and exactly what their latencies are and when they go down and up. We just haven't published the data. One thing that I thought was kind of fun that happened recently was we got picked up by Fresh Air on NPR. Our CEO was like doing this big press junket about how the iOS 8 launch was really bad. We observed some apps that had crash rates that escalated by an order of magnitude, so like 3 to 4% of apps were crashing when iOS 8 first came out, and it was a big problem. So that's kind of how we position ourselves, what we do. So in terms of the talk, I'm going to spend a little bit of time telling you about the external environment of Silicon Valley, like what's going on out there right now in terms of some larger economic forces. I'm going to talk about the job that ops entails, and then talk about some places where I think there's some opportunities, and then some personal reflections on stuff. So, sounds good? All right, cool. And again, thank you for coming out here at 4 o'clock on a Saturday. So, first thing is, let's say you have a great idea. How do you execute on that idea? And it turns out that there's kind of a loop to this. The loop is that you need some people, and it's funny because depending on whether you're like more technically minded or more business minded or more design minded or whatever, you have to crack this cycle somehow. But basically, you have people, and then hopefully people can build this product. But in order to do that, you have to pay them. So if the product does well, then hopefully the product will bring in some money and you can sell it. So then you can get this nice like circle going here. It's kind of cool, all right? It's interesting because if you have a company like GitHub where the founders are very technical, they actually started on this phase right here, where all of them worked without any pay for a while until they were able to get a product together, which they then sold for money and then kind of kickstarted the cycle that way. For people that are a little more business-minded, sometimes they'll start with this by like raising capital first and then going back around the loop over to there. But any way you cut the cards, there's basically 3 ingredients to the sort of early stage ecosystem in San Francisco. And in a nutshell, they're high-skilled ICs or individual contributors. These are people that are actually getting the work done. The developers, the designers, the product managers, the people that are thinking about what needs to be built and building it. The second thing is this entrepreneurial management. They need to be like directed and managed and kind of have people going in the same direction. And the third thing is capital. Now, the reason this is interesting is because right now there's too much of this capital relative to this, high-skilled individual contributors. So what's happened is that software engineering salaries have gone up a lot, and it's gotten really hard to hire. Now, the reason this matters in the context of this talk is that there is a huge demand or interest right now in trying to do as much as possible with as small of a team as possible, because it's just so hard to hire people. You can't hire, even if you wanted to, you just can't hire 10 people because it's just hard to find 10 qualified people. So, as we start thinking about this, realize that the sort of teams that I'm going to talk about here are like 1 or 2 or 3 people, not like 1 or 2 or 300, okay? Alex, in his talk, mentioned that he thinks that Google is behind all this. I actually think there's an alternate explanation for what's driving a lot of this, which is very much about this right here, which is that there's an overabundance of money right now relative to the people. The second of my 4 kind of observations are that this is perceived as the hardest problem right now, which is making something people want. The mentality is that you have to find product market fit first, which means you have to build a product that people want, and that's got to be something that you kind of work on and come up with in your own head. And that's something that an investor is going to want you to come to them with. They don't want to tell you what to build. They want you to bring your idea to them. So that's good. That's the second thing. Third thing is that everybody wants growth, just growth. And it's like, okay, well, what does growth mean? Well, maybe it means growth in your revenue, maybe it means growth in the number of people who work at your company, maybe it means growth in your press mentions, maybe it means growth in eyeballs, whatever, but everybody wants growth. And this is actually true across the broader economic system. If you look at the stock market right now, the stocks that are doing the best are the ones that are perceived to be growing really, really fast. As our VP of BD likes to put it, he says, there's a huge premium on growth assets right now across the entire financial system. I kind of have mixed feelings about this because on one hand, I think that growth can be tricky because if you're trying to work on something that's longer term, like maybe trying to figure out how to make healthcare cheaper, or if you're trying to do something that has more of a research flavor than a development flavor, that it can be hard to show really, really quick growth. But on the other hand, I think the community realizes that it's actually very hard to predict the direction of technology from the get-go. So maybe growth is a decent heuristic for something that's going to be big or something that's succeeding. So maybe that's the best we have. So it's tricky. On the other hand, it's kind of funny because I've seen a lot of these. This is kind of like my little meme here of graphs with no axes. A lot of these companies are doing this where they'll say, just check out our sales growth since we launched in June 2012. This is from a marketplace called Tindy, which sells all these indie products. He's like, oh yeah, it's growing really fast. I don't know if it's from like $1 to like $3 or like $1 million, to $3 million, but we're growing really fast, okay? And likewise, so much growth. This is another actual graph that I found with no numbers on the axes, but again, we're growing really fast. So that's what people want to see. That's what investors and employees and everybody wants to see. And the fourth thing is that dev and ops inside of a company is a marriage. And what I mean by this is that you're going to have some developers and they're going to write some code, and they want a certain set of things in general. And I have worked in both of these camps, so I feel okay like throwing stones at both of them. A lot of the developer people want to use the latest tools because it's cool. Move fast and break things, which was the original Facebook motto. Although some of you might have heard they just changed it in the past week or two. Anybody? Hands up, did you guys hear? It's move fast and scalable infra now, which I think is much less cool than move fast and break things. And the third thing is, in general, software development's all about shipping code and getting it out to people. Operations, on the other hand, is responsible for running the code that the software developers write. So they tend to be like more crotchety and curmudgeonly. Don't fix it if it's not broken. How do I fix this when I get woken up, the pager goes off at 2 a.m.? Is this going to break the bank? Like, is it too expensive? Are you writing something that we need 1,000 computers to run and it's going to be completely intractable? And in general, like, things shouldn't break. Our ops director where I work, Mike Chestnut, Keshav, who I worked with last summer, is probably going to laugh at this. He said, you need a gas pedal and a brake if you're going to drive a race car. You can't just like slam on the gas all the time. You also need to hit the brake every once in a while, okay? So having said that, keep these things in mind as we go forward. So just to reiterate, again, fast growth, small teams, and a huge premium on just getting to market really, really quickly, okay? So part 2 is the job, right? What do you say you do here? So this is the part where I talk about what operations engineers inside of companies do. And I wish a bit that I had spoken before Alex because I think it would have contextualized his talk a little bit better. So the first thing is, I guess just to take a little detour, remember that as I'm talking about this, I realize I'm repeating myself a bit here, that we're dealing with very small teams. I have 3 little stick figures drawn there because I'm about to tell you like 7 or 8 or 9 things that are actually very complicated and hard to do right. But remember that your team is going to be very small. Second is there's always a lot of time pressure because things needed to be shipped yesterday. And third is that there's always change. Things are just changing all the time. The business model changes, the customer requirements changes, just constant change, like all the time. All right, so this question came up during the last session, which was, should I use CoreOS? And the first choice is whose compute and storage should I use? So let's say that you're at some early stage company, you're about to ship a product, and you want to say, like, what is the right compute primitive for me to use? Like, should I use virtualization or Heroku or AWS, or I have a million options, so what should I do? So I want to kind of take inventory of these a little bit, and please feel free to stop me and ask questions because I feel like it's a little bit complicated. So the first choice, which is the easiest, is the platform as a service choice. So this choice here is where you say, and again, I put this in this section because this is something that an ops team usually has to figure out and develop over time. So the first choice here is the platform as a service choice. This is where you have some sort of a provider that you more or less hand code to as a Git repo or SVN or just some sort of a code artifact, and they kind of figure out everything for you. And it turns out that the things they figure out are quite a lot. To look along this axis at the top, they will figure out how to deploy it, which is all about how you take this block of code that's kind of amorphous and just some sort of a Git tree, and like how to move that out onto all of the servers. And that could be quite tricky because in some cases you might have several hundred servers to move code out onto, and doing that in a controlled fashion where you don't cause an outage every time you do it is pretty hard with only a single machine. But when you start to scale it up to like hundreds of machines, it's kind of daunting. You have to do it all at the same time. The second problem is scaling. So this is the question of, okay, like maybe I have 5 machines today, but we actually need double our capacity, so we need to go from 5 to 10. So how do I go about taking this deployed thing and then adding more capacity to it, like dropping more machines into it? The third thing is the network, which is who controls the network. Which ISP are you going to use and what latency do you have to all these other places? And then you have the hardware ownership and monitoring and also power and cooling. So this option, the platform as a service option, this is Heroku. Google Compute Engine falls into this as well. I would actually classify, I see you have the Firebase sticker on your laptop. I would actually classify Firebase in this bucket as well. They're trying to completely eliminate the need for any sort of specialization in infrastructure. I think this is actually a really good bet for you, especially when you're prototyping really early on, because you don't, as Alex said, like the startup guy in him wants the infrastructure to be really janky. Like you don't want to start having to worry about all of like CoreOS and Fleet and Docker, because it's not why your customers are coming to you. They're coming to you because you're making a product that they want. It has to work, but still, it's not why they're coming to you. So I think on the why for this, I said fast cycles. You'll be able to push code multiple times per day, iterate really quickly. That'll be nice. In the personnel column or people, I put 0 to 1 because you don't really need a person to do this. Now, the downside of this is that it's a fairly expensive way to host your software or your code. The Heroku's business model and a lot of the platform providers is that they put a markup in place, so however much capacity you use, they end up buying from some sort of an infrastructure provider and they just like quadruple the price. But the value that they add supposedly is that they handle all of this coordination and scaling and deployment for you, which is actually pretty good. And again, when you're small, it's not really another option. So there's another option is to use one of the infrastructure providers. So this is something like EC2, but Amazon has a lot of infrastructural service primitives, so things like RDS, Relational Database Service, and Dynamo. And this is where they're not giving you computers, but they're giving you actual services. And you can think of these services kind of just as these abstract things that you can use without having to worry about like how many computers it's distributed on and are they backed up, because they generally back it all up for you. It's highly reliable and again, kind of very abstracted, which is nice, high level. Now some of these boxes change. The color code that I'm using here is that the blue boxes are for things which the provider does for you, and the red boxes here, I'm trying to be good to the colorblind people in the audience. The red boxes here are for things you have to do yourself, and green is for things you kind of share responsibility for. So with this mode, you're responsible for your own deployments because you have to push your code out now. You're responsible for your own scaling. The network is kind of shared because you have a little bit of joint responsibility over that, which I'll get into more. But you're still responsible for all this stuff on the right. Why I said network control and price is the big thing. So I see some eyes glazing over. So to go through some more of these options, at this tier you're dealing mostly with things that are services. In this tier, you're dealing with individual computers. That's the biggest difference. And dealing with computers is hard. It means that things are going to fail. You might have to buy hardware or own the hardware, but in any case, it's harder to do all of this. That's why you see there's more people here. You can get some nice benefits like hardcore performance if you use like bare metal colo, where you're running directly on a computer, but it's just more management intensive to do this. You have to know how to do it. It's more risk, but some businesses will need to do this. Are there any questions out of curiosity? Like I'm kind of standing up here and talking. Yeah, go ahead.
So when you're talking about team size,
yeah.
Is there an inherent risk with starting out with a company and eventually switching
Yeah, so that's actually a really good question. And the answer I'd say is yes and no. I would say no because Heroku is actually built on top of EC2. Some people know that, not everybody does. But Heroku is only in one region, so it's only in the US East region, so it's impossible to get your data closer to your West Coast customers. On the other hand, it is nice to get in the habit of having to deal with these operational problems like from day one, because it teaches you to be really good about stuff. And as you said, there's more risk when you have to change from one to the other, because now you have to learn how to do your own deploys and your own monitoring and systems management, all this kind of stuff. And it's something that you might not have known how to do in the past, which means it's going to be tricky because you're not going to have to learn it, all from scratch. And at this point, you probably have customers and revenue and all these kinds of things, so it's not great. Companies do this though, and in fact, there's a big ecosystem of people who will sell you services on top of Heroku, where like Mongo Engine, for instance, they'll sell you like a MongoDB provider that's connectable via Heroku because they actually run on top of EC2. So what else? Anything? So just to take another minute on this chart, like to kind of detail what these are. This one is using an instance infrastructure as a service. So this means you're dealing with individual computers, whereas with this one you're dealing with just kind of this notion of services. And then this one, MSP here stands for Managed Service Provider. This is a company like Rackspace where Alex used to work that helps you manage some of this stuff. A lot of times what people will do is they'll use both something like EC2 or DigitalOcean and a managed service provider because it lets you do what they call own the base and rent the spike, which is where you provision a baseline level of capacity, and then you can add a little bit of capacity using the more expensive EC2 or DigitalOcean above your baseline. It's a little tricky to do that, but it is a pattern that a lot of people use. And then you can also just use, like I said, bare metal managed colo. That's where you actually don't even use a virtual machine container. You run directly on the metal. I know some of the database companies out west that are selling database services do this because they want the really high performance. They don't even want the virtual machine overhead. Like they actually run directly on a single operating system, typically with solid state disks and lots of RAM. And I've seen some of the Mongo hosts that I've seen that do this can push as many as 1 million database transactions a second, which is very, very high performance. So that's cool. And the third tier down here, this is where it gets a little ridiculous, where if you're in this category, you're probably somebody like Google or really big because you have to start thinking about like managing a heavy data center. This one here is bare colo with smart hands, so this means that you're going in and you might have some help at your data center, but ultimately it's your hardware and you're responsible for managing it. This one is where you might have some stuff inside of your own building, and this one is where you're pouring concrete, like just going all the way out to a data center. And again, at that point, the team size, I didn't even bother putting it there because you're basically hiring a whole construction team and pouring concrete at that point. It's a big undertaking. So yeah, any thoughts or comments on this? Yeah, go ahead. Yeah, so the one I work at right now, Criticism, the question was, can I give an example of a company that didn't start on Heroku? So Criticism, where I work now, is not started on Heroku. Criticism went directly to EC2, and the reason they did that was because they knew pretty early on that they were going to be a fairly operationally heavy startup. And just to throw, I realized I didn't do this before, so just to throw some metrics at you, we have a server infrastructure that has about 1,200 VMs in it. We process 45,000 HTTP transactions per second, and we're on about 200 million devices. So we have just mind-blowing amounts of load, like 2 or 3 billion uploads a day that we have to process. So we have all these servers to ingest the information and do classification and storage, and tiered queuing and all kinds of stuff. It's a lot. So I think, yeah, one argument to do that would be that if you're going to eventually have to get into these lower buckets, you might want to develop the competence kind of early on. But again, that's a very nuanced business decision that you have to make as a founder, as an early employee, what you want to do. Anything else? Yeah, go ahead. Yeah.
We have a data center where we're to the point where we have to be careful what we call the end of the capacity in that. A lot of ports go to the cloud, and be careful because at least for certain developments with food, you can't get the guarantee not to see the experience of it.
Yeah. He's commenting about some of the issues with going to cloud deployments. Actually, one very interesting kind of case study on this is the healthcare.gov deployment that happened. They had to bring in a fairly high-level team in order to fix that deployment because it went pretty far off the rails. And there's been a lot written about this. I think that's very interesting about how the culture of working with a lot of the government contractors didn't mesh well with the Silicon Valley culture. So I would encourage you to read that, actually. I think there'll probably be some case studies written about this in the future. So yeah, anyway, I'll continue. So the reason I put this here was that this is something that as an ops person you have to think about. And two little addenda to this are that you probably, the important question is like when you move from here to here, if you ever do. And I think the answer is that really, like in order to be in this category where you're dealing with individual computers, you probably have to be spending at least like 40 or 50,000 a month to even consider going into that. And then down here, you have to be well into the double-digit millions per year in infrastructure spending to even be thinking about dealing with individual data centers and computers yourself. It sounds like a lot of money, but the truth is that Facebook, at least 3 or 4 years ago, more than half of their cost structure was spent purely on infrastructure, not on payroll or offices or anything. So as companies get bigger and bigger and bigger, I say a few years ago because I don't know what it is today, but as companies get bigger and bigger and bigger, their their cost structure tends to grow most in this area as they scale, because that's how you scale and add capacity. So that's the first thing. So one other thing I wanted to mention is that DreamHost style shared hosting, where you have like your crappy PHP host, you know, like somewhere in the cloud, that's not on this list. And the reason I think it's not is that I think that a lot of these types of companies like DreamHost, and actually I put WP Engine in the same bucket for doing WordPress hosting, a lot of them are trying to move toward more of a Git-based deployment, actually. And you know, just kind of as a question, why do you think that is? Like, what do you think is really driving that? Any thoughts? I think I'll tell you. I think it's about dependency isolation, which is that this idea that when you have some sort of a hosting environment, you need to configure all the different libraries and dependencies and tools that you're going to be using. And it turns out that when you're using something like Heroku, there are really good tools for this. In Ruby, people use gem files and bundler a lot. In Python, people use tools like pip. But you need to have a really clean, solid baseline to start from. And if you don't have that, then it's very hard to make sure that your code's going to run without bugs. So on to the next thing. This is another something that Alex got into. So a little note about terminology, because remember also that if you're going to have something that is running all the time, it's really important that you provision enough capacity. So in this context, redundant means that you have more than one of something. Okay, more than one, fine. Okay, maybe you have like more than one disk in your computer, you have more than one of something. But redundancy doesn't get you all the way. And in fact, if you really want to hit like 99.9 or 99.99% uptime where you're dealing with single minutes of downtime per week, something like Visa or a TV broadcast network or whatever it is, you need to start thinking about high availability. And high availability is the sort of system where not only do you have redundancy, but you have some built-in capacity to automatically fail over so that if one thing goes bad, it'll like somehow redistribute the capacity instantaneously in a way that your consumers don't notice, okay? It turns out that building for high availability is considerably more expensive than building without it, because you have to start buying like 2 and 3 times as much as the original capacity that you would have needed to make sure that in the event that when one thing fails, that you'll be able to fail over to all the other things. So, you know, this is an area where a lot of statistics can come into things too, because you have to think about like what is my failure rate that's acceptable and how much money am I willing to throw at this problem in order to make it go away. So as a concrete example of this, and actually the second thing that you need to worry about kind of as an ops person is how do you build your network? So here I have this topology where you have this cloud over here. This is kind of our abstract internet on the left here. And there's a router in the middle, and then there's a computer on the right, okay? But what's the problem with this? Just yell it out. What's the problem with this?
Single points of failure.
Yeah, single points of failure, okay? And why are single points of failure bad? Yeah, any one item takes everything down. Another reason why they're bad is that you can't work on things. So if you need to, if this router all of a sudden needs like a firmware upgrade or something and it needs to be taken offline for a little while, or maybe if this computer is broken and it needs to be taken offline for a while, you have no way of maintaining service, you know, in the face of maintenance. So you have to deliberately over-design. But the problem is that actually adds a lot of cost and complexity. So if you look at this, you go from one router, now you have 2 computers, okay? So now it's like, okay, we have double the capacity here, so I have to pay double as much if I want to support like 10 of something with this, and the capacity that I need is like 15, then this one does 10 and this one does 10, and then I have 20. But you're not really fault tolerant in that case, because if this goes down, there's still going to be a degradation of service. So what ends up happening is that you need to go high availability like all the way back, and to think of the original diagram, which is just this little thing, you know, in order to get to a situation where you can pull the computer out, maybe one of your routers, you know, you really need all of this. Good grief, right? And this is nice because maybe if one of your cloud links goes down, you know, you'll be okay. One of your routers goes down, you'll be able to survive that. And again, that might be a planned event, or it might be an unplanned event. Somebody might arson it, you know, like happened the other day in Chicago. Or, you know, probably shouldn't joke about that. Or these computers on the right. I put this in here because I think the utilities actually do a very good job of this, the public utilities. And I've noticed a lot of things about a lot of different, like in piping systems and in pipelines and gas lines and water lines, all this kind of stuff, that there's a deliberate bypass that's done a lot of times where you can turn something off so that somebody can pull a pipe out and replace it. Because you have to think about how to make things maintainable and design that into your infrastructure. Otherwise, you're going to suffer outages anytime something breaks. So any thoughts or questions on that? Okay. All right, so next thing is you have to figure out is whose network. Just to throw some prices up there, Hurricane Electric right now is offering a special where they'll do $600 a month for a cabinet with 100 megabits per second. So this is actually pretty inexpensive. This is unlimited bandwidth, so you can have as much as you want, but you're capped at 100 megabits per second, and they're charging about $600 a month for that. If you want to go all the way to 10 gigabits per second and you're already in a data center, they'll charge you about $4,000 a month for that. So do these prices seem high or low to people? What do you think? I mean, it's obviously a lot more expensive if you can get a 100 megabit per second Comcast connection for like $100 a month, at your house. But this is untiered carrier grade internet that we're talking about here. So again, just to think about some of the price points. Next thing is, I wanted to talk about this company in particular. They're the person that operates this data center. Equinix is a big data center operator, and I wanted to mention them specifically because they're very good at this. They're very expensive, but I thought they had a very interesting business model, which I think people in the room should be aware of. So I called them Internet McDonald's, and the reason I called them that is that, did you all know actually that McDonald's owns most of the land underneath all of their restaurants? Did you guys know that, all of you? Yeah? So for Equinix, Equinix owns all of these data centers, but what's interesting is that they don't force you to do anything inside of them. So they want to just be the place where everybody comes to. They bring the party to it. So in a typical one of these data centers like this is actually a real thing that I've walked through before. There are anywhere from like 100 to 300 different ISPs that all meet together here. So these facilities like this are where if you're on, let's say, like AT&T and you want to send a packet over to Comcast or over to Verizon, it gets routed through one of these facilities. And their model is that they just want to be the place where everybody meets together. So they will sell you inside of here cages or just space and power. And to put some of the costs in perspective, this is a high availability power grid. These data centers are pretty incredible. They have a lot of times power guarantees where they can run the entire like multi-megawatt data center for 8 to 10 hours without any sort of grid-tied power at all to make it very reliable. And then beyond that, they have diesel delivery contracts so that people will come over and deliver them fuel if need be, in the event of a major earthquake or a power outage. So if you want to run very critical infrastructure, this is where you want to put it, in a system like this. It is pretty expensive to throw some prices around at this, just to kind of get you thinking about this. It's around 50 cents to $1 for every watt. It's 50 cents or $1 per month for every watt of power capacity that you want to put in there. So you think a typical server will use like maybe 200 to 300 watts. So they would charge you anywhere from like $150 to $300 to rack a server in there for every single month that you're in there. This is on the higher end for power. If you go on the lower end, I think you can maybe get to like half of this 50 cents, but you won't be able to get much below that. And I think that's like about, I don't know the exact math off the top of my head, but I think it's more expensive than utility power, but I'm not sure exactly by how much. Any comments on that? Yeah, go ahead. Mm-hmm.
Are they kind of like selling the space and then waiting until it becomes very important?
Yeah, so they do that a little bit because they know that once you're inside of there, it is pretty hard to get out, and that is like a game that people play, and I've seen it played. The question again was like, what when you have a renewal situation where you've been in there for a year or 2 years or 3 years and you want to move, like what happens then? Well, there's a couple ways to combat that. One is that you can have a relationship with multiple different data centers, where maybe you have two of them, one with Equinix and one with Hurricane Electric. Another thing is that you can have a longer term contract for 2 or 3 years, so you get locked into some kind of pricing over time. But these numbers are fairly squishy, like you can negotiate them a bit, and they're also fairly hard to find. Like you won't look on their website and find this, which I find a bit frustrating because it's harder to price out. So yeah.
So what's more desirable about this data center then? Is it the high availability of it, or is it sheer fact that you have all these ISPs together and you can communicate?
So it's actually both. It turns out that in the Bay Area, there are actually 8 separate Equinix data centers. And SV1 is like the networking data center. So SV1 is where you go if you want to have an ISP. And actually, when I walked through there, I saw a lot of like traditional dial-up ISPs like in the racks. I don't want to name which ones, but they were in the racks there. And that's their product that they're selling at SV1. It's the fact that like all the networking is there, but it's more expensive to be there. Okay. In the other ones, like in SV2 and SV5, it's actually about half as expensive to be in those ones because for those, it's more just about bulk compute applications and really highly available power. But you still are about a millisecond or 2 away from this place, SV1. So what happens is they have fiber links that you can use that link their data centers together. But for really super latency critical applications, like you want to be right inside of the SV1. And just to put this in perspective, the transit times on these things, does anybody know in here actually how long it takes for a packet to get from one coast to the other in the United States approximately? Do you know? Anyone? What do you think, Keshav? One coast to the other. It's about 100 milliseconds, actually, to go from one to the other. And if you're inside of one of these things and you're sitting on a LAN and you need to go from one LAN to another, you should expect about half a millisecond or about a microsecond. So when you talk about adding a millisecond or two of latency, that can be a fairly big amount in some cases. I can ping Google from my home in about 3 to 4 milliseconds, typically, just for reference. And it's kind of funny because having been inside of this building, most of my internet traffic that goes from Comcast actually ends up getting peered through this building. And I know that because I can look at the trace route and it says 8 Great Oaks Lane, which is the address of this building. I think that's kind of cool. So the third thing, so remember the first thing is about, what's the compute platform going to be? Second's about the network. Third thing that a lot of people think about in operations say is about delivery. And delivery is this problem of how do we move software from a developer's laptop out into production without causing a huge outage. This was one of our deploy graphics, and our devs love to get on me with this one. The girl's got the house burning down. It's like, yeah, it's your problem now. But more realistically, how do you take a system that's running right now and then push a change out to it so that everything won't go down? And I show this picture here because in a lot of ways it feels a bit like air traffic control because you have all these changes that are kind of moving in and out that you have to coordinate. So a feature is going to go out and maybe there's a bug or something that needs to go out, and you need to get these things sequenced and delivered in a really controlled manner and make sure that you don't cause interruptions and disruptions to availability. It's really bad when you do that. People get really upset and your customers don't like it, and it gets really stressed out internally. So this right here is kind of our process for this. And it's not really important that you understand what all these different boxes mean, but I just wanted to show that there's kind of this controlled sequential process that we use for moving code from development through a lot of gates out to production. This piece right here, this code review and all this branch here, we are actually in the process right now of switching to use CoreOS and Docker, which is what Alex Polvy's talk was about. So the thing that we're going to agree on is the thing that development hands off to operations is going to be a container. And I think that's going to be a more popular pattern in the future as opposed to just a piece of code because it lets you capture all the different library dependencies inside of it. So looking at some of these questions on the right here, what is the DU? So this is the question of what actually gets delivered from your development group out to operations for deployment. Is it an RPM or a tarball or a zip file or just like a piece of code or a container? What is it? Isolated dependencies is an important one. So this is which version of libc are we linking against? Which version of SSL are we going to link against? Which version of libpng are we going to link against? And are we going to use our own or the platform standard one? Like what's the strategy going to be here? And unfortunately, the next thing about the OS, I just want to give you a sense of kind of what can happen when you don't get this stuff right. So we had a fairly bad issue last week where some of our symbolication broke. So this is the process of changing from the stack traces that we capture off of the devices back into source code. The problem was that there was a Unicode character in the title of an app that wasn't being handled properly by our symbolication pipeline because we were using Python 2.7, which has crappy Unicode handling. Some of you might actually know that, all right? Our developer, Sean, actually, tested a fix on his laptop, and he was using an interactive OS X shell session on his laptop. And he tested and was able to verify that this fix went out. This was a bad problem. It was affecting a lot of our customers. But the problem was that when he delivered the fix into operations, he hadn't tested it in the Linux environment. He tested it on OS X. And because everybody was in a hurry, it turns out actually that the BSD system call execve has slightly different semantics than the Linux system call execve. The BSD version of execve inherits whether or not Unicode is on from the environment, which caused a problem where on the developer's laptop, Unicode was enabled, but when we pushed the fix out, it didn't work properly because of the differences literally in a system call in the kernel. So again, you have to make sure that whatever you're testing is what gets shipped out. So that's the first piece. Second piece, this deals more with the test. This is the question of, all right, so now we have some piece of code that we want to deploy. Like, what are the different process gates that we put it through before it goes out? And every mature internet company has to do this. You have somebody, Microsoft or Google or whatever, you write these giant sets of unit tests. And I imagine that if some of you have done internships there, you've probably written this kind of code. Show of hands, anyone? Not too many. Yeah, so you've done it. That's good. I worked in tests for a while, but you write these giant sets of tests. So what happens is you script the execution of these things so that every time you're trying to deploy a change out to production, you do a full run of these. And if any of them fail, you back the change out because you don't want to deploy it. But the model that people are moving toward is that rather than having this be done nightly or on demand, it's done with every commit that moves in so that certain changes are blessed or they're all fine and they can be shipped out to production right away. And the third piece of this is, how does the ops org actually take it and physically move it onto the computer? So the problems here, you have 800 machines in production. You need to make sure that you have exactly the same version of the software on all 800 of those computers, even as disks are failing and network links are failing and all kinds of other problems are happening. You have this problem, which is that deployment is basically a denial of service attack because you have how many hundreds of computers that are trying to pull the code all at the same time. So whatever you do has to deal with that problem as well. And finally, I'm not going to get into this, canaries or config should be in the environment. So I come back to this slide because the other function, this guy's sitting here, this is actually a picture of a naval air traffic controller. I just pulled it off of Wikipedia. This guy here is sequencing the arrival of all these different aircraft. He's also looking at a monitor, monitoring. Monitoring is trying to figure out, what the heck is going on with your system. So to show you why monitoring is important, I want to tell two quick stories, things that have happened in the past year as I was working. So one time at band camp, no, one time we had this situation where we had a very hot storage system. It was getting like thousands of writes per second. It was in Redis. Do any of you used Redis? Show of hands. So it's an in-memory data store. So we had a situation where we had a heavy write load. I think it was something like 5,000 or 10,000 operations per second that was being sharded out into a Redis cluster. And we had our own home-rolled Redis cluster implementation. It was really bad. We had about 8 of these machines, so we were dividing the writes up between that. Now the way we did this is that we partitioned the write load into a bunch of buckets. I think something like 500 or 600 buckets, and then we came up with a hashing algorithm that divided the writes across the different 500 buckets, and then we put something like 100 buckets on each machine. And this was nice because we could add more capacity to it over time. We could shift the buckets around. Now, one fine day, I'm sitting at my desk at like 4:57 p.m. I go to get a Diet Coke. All right, everything's fine. Our HTTP requests are looking good. We're getting normal request flow. 99% HTTP 200 is coming back. Latency's looking good. Everything's fine. All right. I sit down, and then all of a sudden, our chart goes from being like 99% okay to like 50% okay. So we start dropping 50% of our traffic on the floor. Okay. First thing I think to myself is like, what the heck just happened? Okay. Did anybody deploy? No. Nobody deployed. Nobody changed code. Did anybody change the infrastructure? No. Nobody changed the infrastructure. Okay. But we know, we observed that the time it was taking to fulfill a single request went from something like 30 milliseconds to like 120 milliseconds. It basically quadrupled. So we're all sitting there scratching our heads while we're dropping customer data on the floor, which is really bad. So anybody care to take a gander at what had just happened there at 4, I'll give you a hint, it's 5:01 p.m. I'll give you another hint, we're in Pacific time. Yeah, well, so actually, it's funny you mention that because we did have a situation for a long time where Yahoo Fantasy Sports caused us a lot of trouble, but we've since gotten beyond that because everybody would check their phone at the same time. But actually what had happened was that the algorithm that we were using to distribute write load across our Redis cluster had a component in it that looked at the date, actually, and it turns out that that date was in UTC. So Pacific Daylight Time is UTC -7, which means that the day rolls over at 5 o'clock p.m. So what had happened was that by some crazy coincidence of the sharding algorithm, it caused all of the load that was previously distributed across 8 machines to go to like 2, okay? And we had no way of predicting this or modeling this beforehand. And actually, we didn't have the right level of monitoring in place either because the Redis machine was still reachable. It's just that it was taking a much longer time for traffic to get to it and to propagate. So you really need to monitor things is the takeaway from this. And also, design your hashing correctly too, but that's a big and complicated topic, all right? Second story I'll tell about this, that was a hard one, but we solved it pretty quickly. I think we just we pushed a hotfix or something to fix it. But it wasn't something that came up. And another thing I want to point out about that actually is that that's not the sort of bug that you'd necessarily catch in test because the software works properly. But due to the shifting load after it's been deployed to production, there's some sort of a problem that happens. And these sorts of emergent phenomenon are very difficult to predict or debug. But you will have these if you have big systems. So the only solution is just to monitor everything and look for anomalies and changes. But you have to know what to look for in the first place, which is actually hard. The second crazy thing that happened, and this is another Redis problem, was that normally within Amazon, if you have two machines that are in the same data center, you get about a 300 microsecond round trip time between the two machines. It's actually quite fast, 0.3 milliseconds, 300 microseconds. In this particular case, I'm sitting there and all of a sudden, again, everything's going along fine. It's like 7 or 8 p.m. or something, I don't know, and then all of a sudden our graphs dip down to like 50% traffic getting dropped. So once again, I'm like, okay, what the heck? We put the right monitoring in place after the last incident to know when our hashing was incorrect. But in this particular case, what happened was that we had slammed into before I tell you, I'll tell you the symptoms. We sat there with my VP of engineering over my shoulder and found that all of a sudden the ping time on one of these Redis hosts had gone from 300 microseconds across the DC to 10 milliseconds. And 10 milliseconds across the network of a data center is a very, very high amount. That's like pretty much the transit latency from here to like New York City maybe, or maybe to like Ohio. It's really bad. You wouldn't expect it on the same LAN. So we start sitting there, and eventually we broke out a tool called iPerf3. Anybody? iPerf3? So iPerf3 is a tool that lets you dump network traffic information, counters, things like how many bytes are entering and leaving, what's your data rate, all that kind of stuff. We found using iPerf3 that we were transmitting 88,000 packets per second across a gigabit link into this. Now you're like, okay, 88,000 packets a second. What's so special about that? It's not a gigabit per second, even though it's a gigabit link. It's maybe like 100 megabits or 200 megabits per second. But it's funny because I had talked to my roommate about this issue a while ago. It turns out that actually in Zen, which is the hypervisor on EC2, that there's a critical path issue where if you start sending a bunch of really, really small packets, you can actually saturate the link at a much lower throughput than a full gigabit per second. So I'm like, oh, really? So this thing would oscillate back and forth, and it would go down to like 75 or 80,000 packets per second. Then as soon as it hits 88,000, the ping time would like asymptotically rise up to 10 milliseconds. So again, cause an outage. I don't know how the heck we could have planned for this in advance, but bad. Like, crazy stuff. So I particularly like this quote. Werner Vogels is actually the CTO of Amazon.com. His quote is, "Everything fails all the time." And what he means by this is that you have to treat failure of your system as a non-exceptional case. So it's like, you're designing your algorithm or your system or whatever, and you're calling some network service or calling the disk, and you have to have this mentality that this is not going to fail, but when this fails, because statistically, as you have enough machines and your network is big enough, some sort of failure becomes almost constant in the limit case. So you have to think about how to design your software when failure will happen, as it's pretty much a given of a system of the right size. The third thing I'll mention just really quickly is that one day, I think it was like December 2nd or January 2nd or 3rd of this year, I was sitting there looking at our metrics, and all of a sudden we just lost a database machine, just fell off the network. We have no idea what happened. We had the right high availability primitives in place to make sure that we didn't lose any data, and we spun up a new machine after that, but still, like, machines just randomly fall off of AWS. And that's something that as a developer of these kind of systems, you have to take into account as you're designing it. You have to just assume that individual computers will fail, network links will fail, partition events will happen, latencies will go up, just a lot of chaos will occur, okay? This is what to monitor. So I would say the three major classes of metrics are infrastructure, software, and application. So infrastructure is stuff like how much memory is being used and how much RAM is on the machine and how much disk space am I using and what's the load average in the CPU and like all that kind of like low-level standard junk that you can hit if you push like whatever it is, Control-Delete on Windows or whatever it is on Mac, you click Activity Monitor. The other thing you need to monitor is like your software. So there are tools like New Relic, other tools like that they're kind of like profilers. Have any of you used like gprof or any of the statistical profiling tools? We'll probably get a couple of hands in here, right? No one's ever profiled code? Looked at what's the hot paths? Okay, so you have, right? What do you use to do your profiling?
I have used UTROP,
Yeah, do you Shark?
and there's also I use the sampling profiler to build
Okay, cool.
probably not many people know about that.
Yeah, I use Shark a bit on OS 10, but there's actually tools that will instrument your server-side code as well, so that it'll do like a more coarse-grained profiling of your code without imposing a big performance overhead that you can just have all the time. And this is nice because it lets you see if all of a sudden like some piece of your code goes from like 5 or 10% of your wall clock time up to like 50. Something's probably wrong in that case. It also helps you to know what your average request latencies are, so you can kind of get a sense of what the overall performance is. And the last thing is application metrics, and this is particularly interesting. I have a friend who works in site integrity at Facebook, and one of the most important metrics they monitor actually is the percentage of failed logins for people that are going to Facebook. They know that approximately some percentage of every login into that website is going to fail, and if there's a big uptick in that metric, something hostile or malicious is going on, like someone's trying to do a DDoS attack or sending traffic to the site. But the point is that for these kind of increase in value as you go downward, like everyone's going to have the same for this, and that's why it's really easy to buy infrastructure monitoring tools. It's also pretty easy to buy software monitoring tools. These you have to build yourself, your application metrics, because it's going to be specific to every application. For Pinterest, I know they monitor things like how many pics or how many pins they get per second, what number of users they have at a particular time, but every application is a little different. And it's important to look at this stuff because big shifts usually mean that something's going on. It might mean you're just going to get a lot more traffic, but it might mean something hostile is going on as well. So monitor all the things. Yeah. Yeah, so we started off using Nagios. It's kind of crappy though, so we ended up switching to CopperEgg. CopperEgg's a little more expensive. It's made by some company down in Texas, and they're trying to compete with everyone basically. They're trying to do like everything from infrastructure monitoring all the way up through application and everything. It's pretty good. You should check it out. And then we use New Relic for the software monitoring side as well. What else? Anything? All right. So next slide. This is kind of a call for help. I think that when I was here, I was a security researcher for a long time, so I studied vulnerabilities and this kind of stuff. And I think this is a good area for research because there's a lot of different primitives that computer science has to offer, like machine learning and supervised versus unsupervised classification and all kinds of other tools like this. And it would be really great because the biggest problem is that when you have a really large cluster of machines, it's very difficult to separate the noise from the signal in all of this stuff. Like there's always going to be some ambient level of alerting. So for instance, some percentage of our machines almost always are unreachable over SSH because the SSH daemon shuts itself off after enough bad login attempts, and people are just banging on our machines all the time. So if we set off an alert or woke somebody up out of bed every single time that happened, that would be really bad. So we need some sort of a filtering system for all of this. This is a fun one. This is incident response. So this was me at like 3 in the morning one time. Stuff got really bad. I opened up like 8 terminal windows. So this is about what happens when things go wrong, incident response. And it can be very stressful. And it's because something's broken usually. You're either having an outage or you have some sort of a data loss or something's going badly. And you can have a really bad day when this happens. I just wanted to offer a couple of tips that I've learned over the years for how to handle unplanned incidents. I'm using the term unplanned because you can also have some sort of a planned event. If you're doing some sort of an upgrade, you might have planned outages that you've communicated to your customers. But a couple of tips on how to handle unplanned incidents. First one is that there needs to be a person in charge that's designated because tempers are going to run high and people are going to start fighting with each other about what the right thing to do is. Like if a web server goes down, someone's going to say, oh, you should reboot it. Another person says, wait, it might clear up. At my company, we have a pager rotation, and whoever happens to be the on-call engineer, which gets handed off every week, Monday at 10 a.m., they're the person that's responsible for like kind of leading the response effort. Not necessarily for fixing the problem, but for finding the right person that knows how to fix the problem when something happens. And second thing, which is kind of related, is that whoever is your incident commander, or IC, that's the term, or the on-call engineer, as we call them, there needs to be somebody that's in charge of communicating the incident, because if there's not, what's going to happen is that you're going to get people that are walking over all the time or sending you emails and calling you on the phone that's distracting the person that's fixing the problem from actually fixing the problem. So you need somebody whose job it is to like look at the chat system or look at whatever it is and send updates through whatever channels you communicate your updates through. Maybe it's your chat system, maybe you have a status website, whatever it is, just designate somebody to do that job right away because your customers need to know, okay? Third thing is it's really important to keep a detailed log of everything you do, both because during the incident it will be useful, but also after the fact, you're going to want to look back on this and determine what you should change. So write everything down, as things are going really badly. We have a chat system that people use, so we use HipChat so they can kind of chat back and forth. So that's kind of a nice log, but it's important to establish a really accurate picture of what happened, during the whole situation. And actually, a lot of this is copied from the aviation industry. They do a very good job of this. Fourth thing is try not to be in a hurry. You'll fail, but try anyway. But try not to break more stuff because when you're trying to fix something really fast, inevitably you're going to be like really stressed out and pounding the keyboard really fast. So try to kind of stop and take a deep breath before you do anything that has like really big or potentially catastrophic consequences. I have a few more, which is that you have to, thinking in terms of changes is really important. You might have heard me allude to this before when I was talking about the Redis situation. The first thing I said is, well, what changed? If the system goes from a working state to a non-working state, first thing that goes through your head is like, what changed? And a lot of things can change. The external traffic pattern can change. Sometimes the hosting provider will have trouble. Sometimes there will be a deploy or some sort of a software change. But the question is, you always have to say what changed, that between when the system was in a working state versus when it was in a broken state. And like tracking this kind of carefully is useful after the fact as well. So one thing I'm seeing more of now is that there are these systems where they'll do infrastructure monitoring, but they'll also look at your Git commit log, and they'll create this like nice annotated history of everything. So you can say like, okay, at 2:00 p.m. when our graph like went sideways, it's because we did this deploy of this code. So it's easy to kind of cross-reference what happened there. The next thing is schedule a postmortem. This is where everybody sits down, and in a very like blameless Zen-like way, you say, all right, what happened here? And you have to ask, as Mike, our guy, really loves saying the 5 whys. We ran out of capacity. Why did we run out of capacity? Because we didn't anticipate this happening. Why did we not anticipate this? And it's funny because after a little while of doing this, you almost always uncover some sort of a personnel problem or like some sort of a management problem where 2 people weren't talking to each other. There wasn't the right process in place, like somebody deployed something and they didn't change the version of something else, but there's almost always some kind of an underlying communication breakdown that happens that causes this stuff. So you have to be very, very rigorous about following that process. And finally, the last thing is that it's important that if your postmortem identifies any follow-up steps, like for instance, we've had a couple of situations where we were trying to ingest too much data on behalf of our customers. We said, all right, well, we need to put some sort of a rate limit in place so that if we get 1 million crashes a second from this particular customer and this does happen actually sometimes just due to the nature of our business, that our traffic is highly variable. So we've had situations where some of our customers, their back-end services have gone down, and then that ends up cascading and putting a bunch of load on us because all of a sudden their client software starts throwing a bunch of exceptions that they're not handling properly. So that load cascades onto us. Then I get on chat and laugh at somebody at the other company. Sometimes I know them. It's important to get the follow-up steps in order to mitigate this onto your feature or dev roadmap, because the worst thing is when you sit down and everybody says, yeah, we need to do this, it's very urgent, but somehow it gets lost in the weeds, of your priorities to ship, that kind of stuff. So, yeah. And the best part about this is that it can happen at any hour of the day, 5 in the morning, 5 at night, whatever. And there are 2 other things, like 2 other job responsibilities that I want to talk about. One is software upgrades and planned maintenance. So I'm talking about the different activities of an ops organization. This one is about upgrading software and making sure that you're applying the latest patch sets. This is a tricky one because, so this was Heartbleed. So who in this room hasn't heard of this, actually? Raise your hand. The Heartbleed bug. Okay, that's actually pretty interesting because that means the news did a good job of propagating this out. But what happened here, the basic technical summary of this was that there was a bug in libSSL that happened, which caused an issue where somebody could send a packet to a machine that was protected over SSL and grab a piece of memory, which they shouldn't have been able to do. So in order to remedy this, all of the different people that were responsible for maintaining these production servers had to go and replace the version of libSSL with the new version. This is something you have to do. The hard part about this is that, first of all, sometimes unplanned stuff can happen, and this can kind of disrupt your roadmap. The second thing is that there's so much stuff just at any given time. If you have a project of any size, you probably have 100 external library dependencies. You might have 10 different databases that you're using. There's just a lot of different pieces to keep track of and make sure that you've kept up to date and are apprised of all the different problems that have been uncovered and found. This is kind of funny, actually, I thought. So this was Amazon's big developer conference. It's called AWS reInvent. It turns out, actually, that over this past weekend, did any of you hear about the big Zen issue? Show of hands, anybody? There was a very big vulnerability called Zen XSA 108 that happened over the weekend where it turns out that a person that was sitting on top of a Zen instance could crash it without, so all the other tenants of the machine would it would be crashed. So somebody kind of made this little joke, AWS reboot, September 26th through 30th, every AZ, because what else would you rather be doing late night on the weekend? So Amazon had to do a rolling reboot of like half of their production group over the past weekend, and it caused a little bit of chaos for us. But you have to be apprised of this stuff. So I actually think there's a good opportunity here, which I'll elaborate a little bit on more later. There's a few other things too. This is already going a little long, so I would say production engineering, which is like setting up your production image, making sure your logs are draining properly, doing changes, which is anything that has to be scheduled and controlled and done really, really carefully. You're also the tech buyer, and you're the guy who does all the costing as well. So if you're having this conversation where you say, well, we need to build this feature, what does it cost? You need to be able to have an opinion on that. So this part of the talk, I want to talk a little bit about kind of why this is, it's the challenge or the opportunity. If there's anybody looking for something to build a career off of, or entrepreneurs looking for something to do, whatever. There's going to be a lot of changes here. And again, just to get back to what I was talking about before, remember those 3 factors I was saying. Very small teams because it's very hard to hire, very fast schedules, and everything's changing all the time. That's what makes this job hard. So on the delivery side, which is this problem of moving code from development out to production, there's a lot of innovation in this going on right now. This is kind of just a slide of logos, but CoreOS, which is Andy Polvy's company, is doing a really great job with this, along with Docker. But this is a hard problem right now because the software development environment that developers are using to develop code versus what the quality engineers are using in order to verify code versus how it's being run in production, there's differences in those right now. And because there are differences there are unanticipated weirdness stemming from the fact that the environments are different in one way or another. So somebody that can figure out how to A, make sure that everyone's developing on a common environment, and B, make sure that it's very easy to shift things all the way through your full pipeline out to prod, that's a big opportunity right now. And somebody's going to crack that. It's going to, remember that whoever does this, it's got to be done for the whole Java and .NET world, in addition to Ruby, Python, all the different language stacks. So there's going to be space here for tons of small niche players as well as some really, really big people. The second thing is something I alluded to before, which is this whole problem of information overload. So this company right here, actually, they were in my AngelPad class with me. They're called Source Ninja, and they were trying, although they failed, but they were trying to build a business off of this whole problem of keeping track of the security vulnerabilities across all the different open source packages that your code uses, and presenting that to you so that you could say, okay, maybe we need to upgrade this. But having some sort of like a bulleted list of actions where it says, you need to do this, 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 and this. Like, these are the 5 most critical things for you to be able to fix. Nobody has figured out how to solve that problem yet. In a way that lets people take action and actually stay ahead of this stuff rather than always chasing it and being reactive. That's another big problem. And the last thing I would say is that there's this whole area of writing these big, scalable, distributed systems. It's kind of it's a new area, and yet it's not. But like when I was sitting here in Siebel and we were talking 225, there was very much this model of having to deal with data structure and algorithms around a single computer. Not spread across some, to use Andy's term, a warehouse-size computer of crossing the network, doing all this other stuff. And this is important because you learn a lot of things about what you have to log and what assumptions you can make safely, what you can't, the fact that disks will fail, all this kind of stuff. There's a real art to writing software that can run effectively in these very large-scale environments. I think as a personal note I would add here is that I've learned more about Unix than I ever wanted to know in the past 2 years. I know all about strace and dtrace, file descriptors, quotas, limits, UIDs and GIDs, and like every imaginable thing that you could, all the different options to PS. It's like, okay. And yeah, just a few other points on that just to wrap up. I would say it's very important to design blow-off valves into your software. So this is this question of, okay, if we know that if you think something is going to fail or something bad is going to happen, is there some sort of a mode of degraded service that you can put the software into while still maintaining some level of operational stability? So Keshav knows this, that we had a couple situations where we wanted to drop like 1 or 2% of our traffic because we wanted to just trim it down a little bit. We don't make a habit of doing this, but we'd much rather take a very small outage or deliver some lack of availability to a small number of requests than have a total system outage. So as you're designing a big system like this, think about the various like valves and cutouts and things that you can put in to make it both more operable and also some way of putting it into a degraded mode of service so that you can maintain service availability all the time. That's the first thing. I would say the second thing is that data architecture matters. So for Criticism, the company where I work, probably the most important problem we have to solve is actually a very fundamental computer science problem, which is how do we store our data? What database do we use and what level of normalization do we have? Do we use trees? What sort of indexes? All this kind of stuff. And when you have a company like this where processing and storing large volumes of data is your core business, Data architecture is important, and it's something that's very difficult to change later, so you kind of have to get it right at the beginning. Data architecture also includes where your data is physically hosted, or what's called tenancy. This is a big thing with a lot of the stuff that's been happening in the news, like the NSA and everything. People care a lot about data tenancy, and in certain industries, like ad serving, it's really important that you put the data physically close to your end customers, because you might have very, very hard latency requirements. Like if you don't deliver an ad impression within 250 milliseconds, you don't get to serve that ad at all. So spend time in getting this right. I think it's very, very important, data architecture. And the third thing is pay attention to the ops person who has to run your software. Just kind of think about them and try to think about whether or not they're going to have to like wake up in the middle of the night to fix this, do something bad. And finally, I guess just 2 or 3 other things. Pay attention to Docker. I really think that Docker is going to overtake VMs and virtualization in the next few years. It's already getting there. It's like gaining a lot of momentum right now, but I think the fact that it has smaller images and that are faster to deploy, and also I think it's just a tool that's kind of a long time in the making. But if you don't know about Docker, you should probably at least read about it. If not, really take the time to learn it, because it's here to stay, I think. And I think finally, and this is kind of a subtle point, but I don't think you should always aim for efficiency when you build things. And let me explain what I mean by this, which is that if you have some sort of system and it has a certain amount of capacity inside of it, if you're utilizing that system to 100% capacity all the time, then that's going to be very efficient. But the problem is that you're not tolerant of spikes if you do that. And there's always going to be spikes. There'll be outages. Maybe you'll have little peaks in your behavior, that kind of stuff. So never run things at 100%. Maybe run them 70, 80%, but leave yourself a little bit of slack, so that when you have a bad day, or you have to take some sort of a machine out of service or something, that you have a little bit of headroom or coverage. Don't always try to like push as hard as you can in the direction of optimizing things, because it's bad times, and it makes the system very brittle. And all of a sudden, if you trip over one of these things, something bad's going to happen. So that's all I have. It's already 5:10. Everyone's hungry. Thank you very much, and let's talk some more. Anything? Yeah. Yes.
What are the key skills or key mental capabilities you look for in somebody who's trying to able to do
It's funny you ask, because I had this in my notes, but I'm already running a little over. I would say, honestly, statistics. You have to know a lot of statistics. You have to know a lot about a lot of different things in computer architecture and design. You also have to have excellent emotional regulation, because you're going to flip. You're going to have a bad day, and you got to kind of keep it under control. What else? Anything? Yeah, go ahead.
How much does the language that you use to program and put in your server-side code impact how many what the latency is and how many servers you end up flying up? I know I talked to a few recruiters and they were switching over lots of Node, writing a lot of stuff in Node.
Yeah. So the question is, how does language impact servers, number of stuff? My opinion is not much, and I think it's because it's more to do with the patterns that you use. So Node.js is an asynchronous reactive platform, which means that it doesn't block. So what that means is that if you have 100 open connections at a time, they'll each bubble an event, and then you handle those events one at a time. So I actually think I've kind of switched my opinion on this, because I used to think language is really important. I actually think that it's the quality of your architecture, and in particular, if you're using a blocking system when you should be using a non-blocking system, or if you don't have the right algorithms in place, I actually think that has a bigger effect. On the other hand, you're never going to get the same kind of performance out of something like Python that you will get out of C, even though it'll take you much longer to code. But this is actually, it's kind of a side tangent, but this whole shift from blocking to non-blocking reactive software is another thing that I think is here to stay. Polling in single-threaded software, it uses a lot more battery power in phones. It's much less efficient. It forces you to have a single thread for each request coming in. Whereas with Node, you have this nice single-threaded event-based model where you can have 10,000 open connections on a single process and not break a sweat. Go ahead. Yeah, go ahead.
So the biggest problem we've seen is not so much the language, but the number of languages you use. We have a problem with our developers who, I'll write this thing in Java, and this one in Django, and this one in Python. And the more languages you have to support, the more libraries you have to support, different versions. This version of Java needs this version of this library, but this one wants another version. And that, from an operation standpoint, becomes a much bigger hassle.
pretty good. Yeah.
The coolest thing may be really cool to this thing, but now what two cool things that goes just to
Yeah. What else? Anything else? No? All right, get some dinner. Thanks for coming out.